Hi guys, and welcome in the next video. So previously we talked a little bit about the KUKA SmartPad, the KCP. So we know how to use it, so I think it's a good time to actually use it and try to make our first program. So today we're going to do the first program in KUKA Robots. Hope you're excited, and let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, so what are we going to do today? So I'm going to show you how to create a new program, how to create a new folder in case you want to make it and keep everything nicely and organized on your robot. So we're going to go through that. So I'm going to go step by step how to add folders, how to add the new modules. One thing to keep in mind, KUKA Robot is a little bit more complex than FANUC. Therefore, there is more things you need to be aware of. For example, a program in KUKA Robot actually contains two files. Well, it can be also a single file, but we're going to get to that later. But when you create a new module, it's going to create a source file and a .dat file. Now, those are the two files you're going to use. The source file that you have is your program. Let's make it simple. So that's the program you're going to execute, and that's what you're going to see on the SmartPad when you are browsing through the folders and through the files when you have the basic filters applied. The .dat file is an addition to a source file. And the source file takes data from the .dat file. What does it mean is they are merged together. Now it's important notice, because sometimes when you try to copy or cut a program from one folder to another, so basically trying to move the program, you need to remember to copy both files, the source file and the .dat file. Because if you don't do that, then you're just going to get a compilation error, because the source file will say, hey, I'm missing all of the data that is stored in the .dat file. As an example of the things that are stored in the .dat file is our positions. So those who know FANUC robots, they know when you extract the program, everything is in one file, TP file or ls if you translate it, so you can open in Notepad++. So when you scroll all the way down, you're going to see that everything is in one file. On the KUKA robot, it's kind of different. You have the points, and those points refer to the .dat file, and in that .dat file, everything is stored, all of your point information and much more that we're going to talk about a little bit later. Why is it important also that you have two files? Because again, you need to open and edit the file that you want. So if you want to run the program, create everything on the teach pendant and like add movement points, you're going to do that in your source file. And if you're going to add, for example, variables, most likely you're going to do it in your .dat file. That's why I wanted to mention that there are two files, and you need to know more or less what's in one file and what's in the second file. Okay, once we got that sorted out, there is an addition to reading and programming the programs and like understanding those files. So when we're going to edit and add new things to our programs, there's actually quite a few ways how you can display the file. So again, the KUKA is a little bit more complex than FANUC, and the text that you're using, or the kernel language you're using to program it, is a little bit different. So when you will try to open that file just in a Notepad++, for example, you will see that the KRL code is kind of complex and might not be very easy to understand. That's why we're using additional software to view that file, like WorkVisual, Orange Edit, or whatever else you like to use as your software to edit KUKA programs. So why we cannot edit stuff on the teach pendant, you're asking me? Well, you can. That's why I wanted to go and talk a little bit about the filters that you can apply to your program that are going to show more or less of the data. So we're going to go through that when we do the exercises, but basically by default, the only thing you see in your source file when you are trying to edit it is a very easily and understandable information. So it's easy for the operators, easy for the programmers to program and make quick changes. when you go a little bit deeper into that and you want to add variables and other things to your programs, sometimes you need to change the filtering so you will be able to see the program in its ASCII code. Therefore, you got to change the filter, then you want to make the change, and most likely you want to change the filter back, because the next person that's going to be there and is going to work on that program just won't understand what's going on. So that's something I definitely wanted to mention. We're going to also talk a little bit about the difference between select and open. So I think most people that work with Fanuc will be a little bit confused with that. Also, the guys that work at KUKA, probably they wish there was only one button to open the program. But in KUKA we have two buttons. One is select, the other one is open. So with the select button you can actually select a program and make it so the robot can execute it. Using the open, it's kind of, if you're a Fanuc guy, think of it as a background edit where you're going to edit your program. It's not background edit, but you can think of it this way. So select will select the program, make it active, and will try to run, and then you can run it. Opening a program enables you to edit the program but won't allow you to run it. So if you ask me why, the best explanation I'm going to give you is because when you select the program, the data that's in the source file is connected and linked to the .dat file. And actually selecting the program and making changes when the program is selected triggers like an intermediate action that the program recompiles. Like every time you change something, you can think that the program recompiles and checks. That's why it's often when you just edit the source files, you will get a lot of errors, even though there is in theory no error. But that's because it's trying to link some information to some external source that maybe doesn't exist yet. So that's why he's giving a compilation error. So whenever you're going to change the program, well, not for the touch-ups, of course. If you do the touch-ups, you're going to do the select. But if you want to add some logic to it or some text or something that's not possible to do by standard buttons, then you want to open it instead of selecting it. But we're going to get to that, to the exercises. We're going to also briefly show you like how to add the commands to the program, like points and a little bit of logic. And that is going to be our conclusion for our first program. So we're going to add a few points, a little bit of logic, and you can train and try yourself how the program works. You can program your program at your robot and let me know down in the comments if you like it or not. If you're ready, let's get to the exercises.
Hi guys, and welcome to the exercises. So today we're going to create our first program, add a little bit logic to it, so you will see what we will be dealing with in the future. So first thing first, always it's a good habit to log in as an expert because it will give you much more opportunities and much more options to modify your program. So first thing, we want to log in as an expert. So let's do that. Okay, once we are logged in as an expert, you can see that the first difference is you see two files. Like I said, your main program has a source file and a .dat file. That's because the modules are always joined and created out of the two files. And I'm going to show you in a second what does it mean. So it's also important if you have the left window or the right window selected, because when you have a left window selected and when you hit new, you are able to create a new folder. But when you have the right window selected and you hit new, then you can create a module, a function, sub-interpreter. We're not going to talk about those today. The only thing we're going to care is the module. So when you select the module and you click OK, you are going to create a new module. And let's name it new. So we know that that's something that we created right now. And let's hit enter. And as you can see, by default, you're going to have new source file and new .dat file. This way, you will never forget about creating one of those. So like I said in the introduction, the source file and .dat file are connected together. And when you create a new module, by default, you're creating both of them. So let's see what does it mean. Or actually, before, I want to show you one more, let's say maybe not a trick, but one more option. So when you hit edit right now, and when we're going to select filter, we can select if we want to see just the modules or we want to see all files. So when you select modules and you hit OK, you are just going to see the source files, which in some cases might be a little bit easier and better to handle because you might have a lot of programs and you don't necessarily want to see the .dat files. So you want to change the filter to the modules only. But that's something to keep in mind because sometimes you might be looking for that .dat file like, oh my God, where is it? And you just simply forgot to change your filter. So you want to do the filter, you want to do detail, you want to hit OK. And this way you're going to see your programs. Okay, so let me show you what's inside the default programs that you will create. So first of all, let's select it. As you can see, the selection is active right now, and you will always see the same thing, which is going to be your init line, and by default, you're going to have 2 home positions added. Now, in KUKA, there is one thing that's very important, and that's open and close fault. So all of those are kind of functions, actually, faults. But just so the user can see it easier, they are being compressed to like that single line. So if you're going to select a line by clicking a block selection, so the block selection allows you to move the program pointer to a line, and you click open close fault, you can see that actually this command holds all of that information. But just for us to see it better and be a little bit easier to read, it's being hidden for us, so it is easier for us to understand. Now, you already seen the block selection. So the block selections allow us to move the program pointer to the line that we will select. So if I will move my program pointer, the selection here, but we want to run, we're actually going to run from this point, not from that point. So we always have to click the block selection in order to make the selection kind of active. And one more thing that's very important, whenever you're going to select a new program, so if you have had other programs selected and you selected a new one, you don't want to move directly to a point. You always want to go through the init line, and you always want to make sure that the init line is being executed before you move. We're going to get that also later. Just keep that in mind for now. You always want to select the init line. You might want to solve the robot to like 0% and just run the init line. So the robot will execute all of the information that's stored there. And then you want to select whatever point you want. It can be in the middle of the program and then execute it. So before we add anything to that program, there is one more thing I wanted to mention, and that's your so basically your program icon in here. So you can cancel the program or reset the program. Canceling the program basically is going to go out of the program and make the robot able to select some other program. Hitting the reset program will move the program pointer to the first line. So if we're going to be, for example, in here, we're going to execute the program and it will stop here, and you're going to do reset program. As you can see, the program pointer automatically jumped to the first line, and you can restart the program execution. If you want to execute the program, again, you want to make sure that you select the program. It is always a good habit to clear all of the error messages to make sure when you execute the program, nothing is going to stop it from executing. Enable your robots, and then simply click the play button and allow the robot to run. So as you can see, the robot is moving right now. I am holding the play button. We're moving to the home position, but the robot is not really moving because we're on a 0%. So you want to speed it up. And this way, the robot started the movement. It's going to the home position and it's executing the program. Because we are in the run mode, we're going to just smoothly in the go mode, we're going to smoothly execute through the program. But there is one thing That's important for KUKA. So that's program path reached, BCO. Why is it in here? The KUKA executes the program a little bit different than FANUC. And in order to be able to coordinate the motions and the logic, let's make it simple, you always have to be on path. So basically what's happening right now, this information tells us that the robot movements and the program logic has been synchronized and the robot can execute the program. So for example, in FANUC, you're able to jump into the program, click wherever, and you can move over there. And the robot can even start in auto. In KUKA, because of the way how the program is being executed, that's not possible. Always before you will be able to change to auto, you have to have the program path reached BCO, otherwise you won't be able to execute the program. Because even though I'm in theory all the time holding the key, you can see the program is stopped and nothing is happening. That's because the robot was waiting for that BCO, okay? So now we can confirm and run it. So the program ran to the next point. Now the program finished running and you can see that the black icon indicates that the program stopped executing. So the program pointer is gone. That means the program has finished its execution. And now when you hit reset, we are going to jump to the beginning of the program. How do we add points? So we're going to select the line. It's always good to click the block selection because this way you're making sure your program pointer is going to be where you want it to be and you won't run the program from some other point. So basically, everything is located in here in that bottom menu. So we have our motion command, and that allows us to choose what type of motion is it. Is it a point-to-point, linear, circular, spline movements? Then it enables us to rename that point. Is it a fine movement or a continuous movement? We can change the robot speed and the point data. So then if you click OK, command OK, the robot is automatically going to create a point and is going to apply a tool and base to it. So in FANUC, we need to define the tool and base before the movement. In KUKA, tool and base are stored with the movement point, so you never need to worry about selecting the correct tool and frame before running the program. Then if you're going to move the robot a little bit and you want to save the point, you simply are going to hit the touch up. So you're going to select the point you want to touch up, you want to hit the touch up, and the KUKA will tell you, hey, are you sure you want to touch up the point? Yes, we do. And you're going to get the message that current coordinates have been applied to your point P1. So that's how you add a point. And one thing that is left in our program creation is adding a logic. And we're going to add the logic by hitting on the commands. And in here we have a lot of options. You can also add a point. You can change motion parameters, or you can add the logic. So let's say we want to wait for something. So you want to hit wait, and let's wait for 5 seconds. And you want to click command OK. So in here, it's a little bit maybe programmer friendly than in FANUC, because whenever you're going to select and add new things, it will always automatically fill the things out for you, so you can select whatever you want. And after you're done, just do command OK. If there is something that you want to change, then you want to simply select the block that you want to change. You want to hit change, and then you can change to whatever you want and hit command OK. So that's how you add the logic or other commands to your program. And one thing that probably I want to show you is adding a comment. So the easiest way to do it is by hitting the pencil icon, and then you want to add a semicolon, and you can type a comment. And after you're done, simply just close it, and the comment is added to your program. And when you are done, you can simply cancel the program, and all of the changes will be stored. Now, what's important, we did the select action in order to run our program. But whenever you want to do more complicated things, or actually whenever you want to modify the program by adding a logic, you should use the open, So you hit the open, and then you see, in theory, the program looks the same, but open acts different than select. So select actually makes the program active. As you can see, when we hit open, the program has not been selected. And the reason why you want to edit your program while being in the open, not in the select, is because when you select the program, the robot is constantly kind of like monitoring it and linking everything that's happening to some actions. And if you make errors during your changes, or something that your program is not the best, you might get like an false errors, a false negative, that something is wrong, but it's not really wrong because you're still modifying the program. So it's always a good habit to change your programs using the open and not the select button. Of course, if you're touching up a point, you will do it using select because you want to execute the program. But if you're adding comments, adding logic, always try to do it using the open icon. All right. What's also important is the view. So as we change the view in our program view, you can also change the way how the program looks. So we do that by hitting edit and then view. And then you can select what you want to see and what you do not want to see. So for us, the interesting is going to be the detail view. So when we click it, you can see that a lot of things changed. All of the folds opened, and you see much more. You see now your definition. In here, you see the end line. When we're going to disable the ASCII view, you see much less. So we're going to make use of it in the next videos, in the upcoming variable videos. For now, let's do not focus on that, but keep that in mind because we're going to use those later on. But for your regular programming, the view that you have right now, so the line break view, is probably the best where you can see your program. Okay. Also right now, as you can see, you cannot close that program because it's not being selected. You're going to close it by hitting the X. And if you will make any changes, actually, let's make a change. Oh, sorry, we're going to get to that in a second. If you make a change, so let's say you're going to add a line and we're going to add a new comment to it. And you will close it, it will ask you, hey, something has changed. Do you want to save the changes? Yes, we do. And everything is going to be fine. If you're going to make a mistake and you're going to add something that doesn't exist, you will get a compilation error. So the X right now shows basically that something is wrong with the program. And as you can see, the select button that you have is no longer available, and you have only the error list. So when you hit on error list, it will actually tell you, oh, hey, something is wrong. In our case, let's say that's expected. It's not actually the error that we have. But when you hit the display, it will take you to the line that's faulted, and you can fix your error. So in our case, adding the semicolon. You can close it, we'll save, it's going to recompile, and right now your program doesn't have any more faults. So that will be pretty much all about our source file. What about our .dat file? So let's open that. Sorry. Let's open that. So as you can see, there are some declarations. there is some additional data, and there is some space where you add new things. So all of that is basically the information that are linked to your points. So in our case, because I added a new point, the new point showed up in here with the xp1 is our point 1 and it has the coordinates. If you open the .dat file, by default, it will only hold the information that is stored in that program. And you cannot use that information for the other programs. What I mean is that file is linked with that program. That file is linked with that program. In order to make the data in that program available for other programs, we need to make some changes, but I'm going to talk about this in the future videos. So just so you see, one more time, your point 1 with p.1 is actually stored in your .dat file in here. It's stored as a Cartesian position, your p1, and all of the point data is stored here, as well as like what tool is it, what base is it, and a little bit more information about the speed, about the acceleration, and other things we'll talk about a little bit later on. And that will be, guys, pretty much it from the creating your first program and adding stuff to it. We're going to create more complex programs later on. I just wanted to make a quick introduction to it because in the next video we're going to talk about variables, and when we know how to create the programs, how to select the programs, then we're going to execute them, and you're going to see how the robot acts using a different type of motions, changing the motion types, and so on and so on. So stay tuned, and thank you for the exercise. Bye bye.
All right. I hope you liked the video. Like always, don't forget to leave your comments down below. Give it a like, subscribe, and see you in the next video. Bye bye.